Welcome to the deep dive. So you submitted some really fascinating sources describing, well, something pretty incredible. A persistent, non-arbitrary digital world built directly on Bitcoin's core data structure.
Yeah, it's a big idea. We're talking about using, I guess, the most immutable record we have, right? Bitcoin's ledger.
Yeah.
Using that to actually define a digital reality.
Exactly. And our mission today is really to unpack this thing called Bitmap. It's blown up recently.
It really has. And it's not just, another NFT collection. It's being treated as a new kind of social consensus standard. The idea is it transforms every single Bitcoin block into a piece of virtual real estate.
Right. And we're looking specifically at how everyone's scrambling globally to standardize how this new world gets built, how it's valued, indexed.
Especially given how fast the market moved on this.
Absolutely. The velocity is key here.
We've got the original Bitmap Theory white paper, some really interesting commentary from builders, X-Spector, Jack Liu from OrdSwap.
And transcripts discussing this whole standards race, which seems to be the main event right now. It does. The core insight, it seems, is creating this persistent virtual world that doesn't depend on one company's servers or decisions. It just inherits Bitcoin's own permanence.
That's the hook, inheriting the security and the longevity.
Okay, let's dive in then, starting with the theory behind it all. How does this actually work?
So Bitmap is essentially a set of rules, a consensus standard that maps Bitcoin's data spatially.
Spatially, so like giving dimensions to data.
Exactly. The theory calls it a transmutational metaverse standard. It's transmuting transaction data into, well, geography, verifiable, potentially 3D virtual geography.
Huh. And that ties into this digital matter theory, or DMT, right?
Precisely. DMT is the philosophical underpinning, maybe. The idea is pretty straightforward, but quite powerful. Bitcoin blocks themselves are the original digital matter. They're the immovable objects in the digital realm.
Because they can't be changed once they're mined.
Right. So by using these blocks as the universal metaverse seed, any world built on top automatically inherits the permanence of the Bitcoin time chain itself. It's guaranteed to last as long as Bitcoin lasts.
And that non-arbitrary value point is huge here, isn't it? I mean, you look at older metaverses.
Oh, yeah. They just, picked a number. We'll have 100,000 parcels or whatever.
Right. Totally arbitrary scarcity. But with Bitmap, the amount of land, its existence, its growth, it's all tied directly to Bitcoin's own block production. The mining process itself generates the world.
It completely removes that governance risk, you see. The scarcity isn't decided by a CEO or a foundation vote. It's guaranteed by proof of work, by the energy spent, by the decentralized consensus of Bitcoin. That's the fundamental shift.
That's what the market seems to be reacting to.
Absolutely. That's driving the valuation.
Okay, so based on that theory, what's the actual structure? How's it laid out?
It's layered. The Bitcoin blocks themselves, each one represents a district.
A district, and how do you own one?
Ownership is claimed by being the first person to create a specific ordinal inscription. It has to follow the format blockheight.bitmap. So first come, first serve for each block number.
Okay, simple enough. Districts are claimed via inscription. What's the next layer?
Inside the districts, you have the individual Bitcoin transactions that were included in that specific block. Each transaction represents a smaller unit, a parcel.
So blocks are districts, transactions are parcels.
Exactly. And this whole layered approach is codified by something they call the TRIP framework. Stands for theory, rule set, index, and product.
TRIP. Okay. And you mentioned something about rule sets needing to be resolvable and repeatable. That sounds important, if a bit technical.
Oh, it's absolutely vital. It might sound academic, but it's about preventing, reality forks. Imagine if different people, different indexers, say one in Tokyo, one in London, if they interpret the parcel data using slightly different rules, they'll literally see different maps, different boundaries, different owners. The whole shared reality breaks down.
I see. So the rules have to be crystal clear, mathematically precise, so everyone, everywhere, computes the exact same geography from the same block data.
Exactly. Repeatable, resolvable. Without that, it's chaos. No shared metaverse.
Okay, that really sets the stage for understanding the market's reaction. The theory promises this permanence, this non-arbitrary foundation.
But permanence only matters if people believe it, right? And act on it.
And they certainly acted. This blockout phenomenon, claiming all existing Bitcoin blocks as districts, happened in just 17 days.
17 days. It was astonishingly fast. Shows just how much pent-up demand there was for this kind of concept. The recognition was almost immediate.
And the scale we're talking about. How does it compare to, say, established Web3 projects?
Well, the comparisons are pretty striking. Take valuation. Just the land value layer of Bitmap, the districts, its market cap blew past Decentraland's entire land market value pretty quickly.
Really? What are the numbers, roughly?
We're looking at Bitmap's market cap around $185 million plus, maybe more now. Decentraland's parcel value is estimated around $100 million.
Wow. For something that was basically theoretical weeks before.
It really underscores the market's hunger for that protocol-guaranteed scarcity we talked about. It's not just hype. It's valuing that fundamental difference.
On the sheer number of assets.
That's the other thing. You've got roughly 800,000 districts initially, corresponding to the block's mined up to that point, and potentially 850 million parcels within them.
850 million. That's enormous scale.
It is. And it puts the holder count right up there, neck and neck, or even surpassing major projects like the Sandbox or Yuga Labs' other side.
So it's not just a niche NFT thing.
No, not at all. The scale is why people are calling it a hybrid token. It has the uniqueness of NFTs. Each district is tied to a specific block, but the sheer volume gives it properties more like a fungible asset, potentially much more liquid.
Which naturally shifts the focus. Once all the initial districts were claimed in the blockout,
The focus instantly pivoted. It went from grab the land to, okay, how do we actually use this land? Specifically, how do we define and interact with those 850 million parcels?
right, because you can't build applications or experiences if you don't have a common language for the smallest units of space.
Exactly. Developers need a universal standard for inscribing, identifying, and maybe even subdividing parcels within their districts. And because there wasn't one immediately obvious, cue the standards race. High stakes.
Okay, let's break down the main contenders. First up, there's Bliss. That's the bitmap lot inscription standard from Haste Arcade.
That's right. Bliss aims for a very mathematically pure approach. It uses standard Bitcoin tools like the SHA-256 hash algorithm and base58 encoding to generate unique identifiers for lots or parcels.
Okay, using crypto standards. And how does it define the size, the square footage of these parcels?
This is interesting. It uses the virtual bytes, the V-bytes from the transaction data.
V-bytes. Remind us what that is in Bitcoin terms.
It's basically a measure of transaction size and data weight on the Bitcoin network. It reflects how much block space a transaction takes up, considering things like SegWit discounts.
So Bliss repurposes this technical network metric
As the geometric size of the parcel. It's trying to use something inherent to Bitcoin data. But, crucially, it still seems to need extra information, like predefined size labels, small, medium, large, and a specific project name to fully resolve the lot.
Okay, so it's mathematical, but maybe with some added layers. What about the other main proposal, Bitplot? It sounds different.
It takes a very different tack. Bitplot seems more focused on, let's say, financialization derived from the block's history.
How so?
It looks at data within the block, like the total number of transactions, the amount of Bitcoin transacted, maybe the miner reward, and then it multiplies these historical data points by an arbitrary factor. They chose 21.
21. Why 21?
Well, that's the question, isn't it? It seems arbitrary. And the result of this calculation generates something they call plot tokens. It essentially creates a new type of token, a commodity layer almost, tied to the characteristics of that district's history.
But wait, introducing an arbitrary number like 21?
Yeah.
Doesn't that kind of violate the whole non-arbitrary principle that makes Bitmap appealing in the first place?
That is exactly the core debate raging in the developer community right now. That's the philosophical friction point.
So builders are pushing back.
Many core builders, yes. They argue that both Bliss, with its project names and size labels, and Bitplot, with its arbitrary multiplier, introduce too much complexity. Too many layers of an interpretation that aren't strictly native to the raw Bitcoin block data itself.
And that complexity leads back to the problem of needing central authorities, right?
Yeah.
Centralized indexers.
Precisely. That's the main objection. If a standard is too complex, if it requires interpreting nested inscription data or applying arbitrary rules, then it becomes very difficult for just anyone to independently verify the state of the world.
You become reliant on big players, like Unisat or maybe others, to tell you what the map looks like.
Exactly. You need their indexer to resolve the complexity. And if you rely on a handful of indexers, have you really achieved decentralization? Or have you just swapped one form of central control for another?
So the push is for radical simplicity.
Yes. Simplicity, repeatability, resolvability directly from the chain data. The goal, as some put it, is a TCP/IP for the metaverse.
Like the basic communication protocol for the internet.
Yeah.
Something universal and simple that everything else can build on top of.
Correct. The standard needs to be simple enough that any application, whether it's built using Unreal Engine, Unity, 3JS, whatever, can query the blockchain or a simple indexer and get the exact same geographical data, the same parcel boundaries, the same ownership, instantly and reliably.
Without trusting a specific company's interpretation.
That's the ideal. And it relies heavily on having multiple independent decentralized indexers, like the track protocol is aiming for, that can all provide that stable, mathematically consistent view of the data's provenance. It's essential to prevent fraud or accidental forks in reality.
It's fascinating. The battle has truly shifted from claiming territory to defining the fundamental language of this new digital geography. Okay, let's look at who's actually building things already, the early movers.
Yeah, there are projects jumping in. Xpector is a good example of a team going all in. They apparently secured over 3,500 bitmaps, so a significant holding.
Wow. And what's their approach?
They're building a fully distributed metaverse architecture using Unreal Engine 5, which is pretty high-end. But the key part is their architecture. They emphasize separating the 3D content, the experiences, from the blockchain land ownership itself. Meaning users could potentially run their own 3D servers to host the content associated with their land. So if Xpector as a company disappeared tomorrow, the land, the bitmap, is still yours on Bitcoin, and the content could, in theory, be served from somewhere else. It avoids platform lock-in for the visuals.
That sounds resilient. And they have a bigger vision.
Yeah, they talk about creating an app store layer, they call it MetaZone, where creators could deploy experiences onto the bitmap land.
Interesting. Decentralized hosting, app store layer. It's ambitious. But what about the bigger picture, the financial side? Especially with, what was it, 800,000 plus districts out there.
That sheer scale changes the financial game. Jack Liu from OrdSwap made some really sharp points on this. He sees Bitmap not just as an NFT, but as this hybrid asset class because of its massive scale.
Right, the hybrid token idea again.
And that scale enables financial products that just weren't practical for smaller, typical NFT collections.
Like what? Ways for people to invest without having to actually manage the land.
Exactly. They're talking about concepts like an OrdSwap Bitmap Trust. Think of it like the Grayscale Bitcoin Trust, GBTC, but for Bitmap.
Okay, so institutional investors, or maybe just individuals who don't want the hassle, could buy into this trust.
And get broad exposure to the entire Bitmap asset class, benefiting if the overall value goes up, but without needing to custody hundreds of individual Bitmap inscriptions or figure out how to build on parcel number 17 of block 700,000,
That could bring in a lot more liquidity. Makes sense.
It potentially bridges the gap between this raw digital land and traditional finance.
And just to reinforce the long-term vision here, the idea is that no matter how the front-end tech evolves, we move to Apple Vision Pro, neural interfaces, whatever comes next.
The underlying data layer, the bitmap districts and parcels defined on Bitcoin, remains permanent, unchanged.
So the vision is this dynamic ecosystem built on a permanent foundation. Developers deploy apps, commerce happens between landowners and creators all across different platforms and interfaces, but anchored to the Bitcoin chain.
That's the dream. Utilizing Bitcoin not just for money, but as the bedrock, the unchangeable foundation for a persistent digital reality.
Well, this has been a really comprehensive look. The theory, the market explosion, this critical standards battle, it's a lot to take in.
It really is. Bitmap feels like a truly foundational starting point, non-arbitrary, built on the most secure digital ground we have. But we're absolutely in the messy, crucial early phase.
Finding the rules of the road.
Exactly. Defining that TCP/IP for the metaverse, building the indexing infrastructure needed to make it all stable and usable. That's the work happening right now.
It's incredible that we went from, what, an obscure inscription type within the already niche ordinal space?
A globally discussed, multi-million-dollar asset class with protocol guarantees in literally a few weeks.
The speed is just mind-bending. It really shows the demand for digital property rights that feel
real,
permanent, rooted in something solid.
Absolutely. And maybe here's a final thought to leave people with. If the early web was about websites fighting for eyeballs, maybe this next phase, this metaverse built on Bitmap, maybe it's about competing rule sets, fighting to become the dominant universal language for defining digital reality itself. Which standard, Bliss, BitClaw, or maybe something simpler will actually win that consensus? And how will that choice shape the actual geography, the very map of this emerging permaweb?